What's up everyone, Patrick here, welcome back. And in this next question, we have to graph the region bounded by these two inequalities here. So 3x minus y is less than or equal to 2, and then x plus 4y is greater than 12. Now, when I get something like this, where we're solving an inequality system, I actually like to look at these separately first, and then combine them. So starting with this first one, what do we do here? Well, we isolate for the y. So the negative y, because it's a negative here, I'm going to bring it over, then I'll bring the 2 over. So we'd have 3x minus 2 less than or equal to y. So which means y is greater than or equal to 3x minus 2. Okay, so if we graph this, let's make a good amount of room here. Let's actually try to keep this to scale. I try to keep it to scale. If I'm working with just one inequality and I'm graphing the solution for it, then there's a little bit more flexibility with just kind of graphing it with no scale. But when you're going to be combining two, then the scale starts being fairly important. So this line here, 3x minus 2, notice that 0 and negative 2 is the, so if we rewrite it, it's the b value, or the y-intercept. If we wanted to get the corresponding x-intercept, we can plug in 0 for y, bring the negative 2 over, divide both sides by 3, x would be 2 over 3, which would be like 0.66, so that, this is like 1, so that would be like over here. Right, so this point would be 2 over 3. And 0, so if we combine those points, we'd end up getting that line over here. Now, going back to the inequality, it's all the y values that are greater than this line. So it's all the y values above this line. So basically, this here, which is the same as this, the region, if we were to draw it, I'm not going to draw it yet, but if we were to draw it, it basically would be this region. So what I'm going to do is I'll put just a few arrows over here coming out of this line. I'm not going to shade in the full region because I want some room to graph that other line as well. But if we're just looking at that first inequality, this here would be the solution. So this is the line, and then it's all of this region here. Now, because this was less than or equal to, this is greater than or equal to. Remember, this and this are the same thing. This here is a solid line that we graph. If this was just greater than this line, then it wouldn't include the points on the line, and so this would be a dotted line. Right, but because it's greater than or equal to, it's a solid line, so it includes those points. And then the next line will have x plus 4y is greater than 12. Here, the y is already positive, so I'm going to bring the x over. It becomes negative x, and then divide both sides by 4. We don't have to worry about flipping that inequality because we're dividing by a positive number, so y is greater than negative 1 over 4x plus 3, like that. All right, so this line here, notice has a b value of 3, which would be here. And then it's going to have a negative slope, so the line's going to go this way. What I'm going to do actually is find, so we know the y-intercept is 0 and 3. What would be the, if we have it as y equals negative 1 over 4x plus 3, what would be the x-intercept? We'll plug in 0 for y. Bring this over, 1 over 4x, is equal to 3. Multiplied by 4, x would be 12. Another quick way to do this, to get this, is you can just write x plus 4y is equal to 12. And if you wanted to get the y-intercept, plug in 0 for x, divide both sides by 4, and you would get that 3. And then to get the x-intercept, you plug in 0 for y, and then we'd end up with x is equal to 12. But then you have to still take this and then isolate it to get this, to know that after you graph the line, is the region going to be above the line or below the line, right? So the x-intercept is actually going to be at 12, so that's going to be way further down here. And so if we pretend that we're going to go to 12, we can sort of make a line like that. And it's basically going to be all the y values above this line, right? Because we have this here. Now, because it's just greater than, not greater than or equal to, it's actually going to be a dotted line here. Like that. And what we have to shade in is basically the region bounded by both this and this, right? Bounded by both these inequalities. So the first inequality, it was basically, if we extend this line a little bit more, just to show this, it was basically the region above this line, right? So all of this here, if we shade it in, versus with this inequality, it's this region above. And so when you're looking for the region that's bounded by the inequalities, it has to be the region that's shared by both. So notice, for example, like this region, it's part of this first inequality, but it's not part of the second inequality because it's all the y values below. This region, it's part of the second inequality because it's above this line, but it's not above that first line. So it's not in the region of the first inequality, right? This one here, it's this region over here is actually not in either of the inequalities. So the only region that's shared by both would be this region over here, right? And that would be the answer right there. And yeah, you can actually test this too. So you can pick a point, for example, within this region. So if this is at 0 and 3, then we know that we're going to have a point like 1 and 4, which would be within that region. Notice that if we take 1 and 4, if we plug it in here, notice we'd end up with 3 minus 4, so we'd end up with -1 is less than or equal to 2, which passes. And then if we plug in 1 and 4 here, we'd end up with 1 plus 16. 17 is greater than 12. And that point would pass as well. So once you shade in that region, you could pick a point within that region. Just make sure it's within, right? That's why I suggest drawing out these graphs to scale when you're dealing with multiple inequalities. When you're going to graph the region bounded by multiple inequalities, draw the graph to scale, then it's easy to pick a point in that region and then test it for both of them, and then both should pass. All right, so the way I do this, I work with each separately first. I don't fully shade it in just to leave myself some room for the second line. Then once I graph both lines, I kind of just find that region that is shared by both inequalities.